All right, viewers, welcome back to my YouTube channel. Hope by the grace of God, the glory of God is shining upon you. Right, in today's video, we have a question on the board. Quickly, let's see what the question says and see how we can go about it. The question says, capacitors of 2 microfarad and 6 microfarad are connected in series to a 240 volts DC supply. Calculate A, the equivalent capacitance, the charge on each capacitance, the PD on each capacitor, and the energy stored in each capacitor. So, first of all, let's draw our diagram. So, our diagram, we have C1 plus C2. So, this becomes our diagram. Alright, so we have 240 volts DC. So, C1 is what? 2 microfarad. And C2 is what? 6 microfarad. So I want us to use the A. We are asked to calculate the equivalent capacitance. We can either use, we can either use the 1 over C formula, or we can use 1 over C formula, which is 1 C total 1 over C1 plus 1 over C2. And here we can also use the product over sum, that is C1 times C2 over C1 plus C2. So let's see what we have. So 1 over C total, 1 over C is what? C1 is what? 2, C2 is what? 6. So 1 over CT, 1 divided by 2, we have 0.5. Then 1 divided by 6, let's do it and see. 1 divided by 6, we have 0.167. 0.167. Alright, so let's see T stands alone. 1. Let's add this value and see. 0.5 plus 0.167. We have 0.667. The answer that we'll get here should be smaller than the total capacitance. The answer should be smaller than the smaller capacitor. So the smaller capacitor here is what? 6 is 2 microfarad. That is what we use to check whether your answer is correct. So let's see and see. If we get lesser than 2, that means our answer is correct. So 1 divided by 0.667, we have 1.499, which is 1.5 microfarad. So you see we have 1.5. In series circuit, your total capacitance should be lesser than the smaller capacitor that is connected in series with the others. So let's use the product over sum. CT, we see that we arrive at the same answer. So C1 is 2 times C2 is 6. So C1 2 plus 6. So CT, which is 12 over 8. So our CT, so 12 divided by 8, let's do it and see whether we have 1.5. 12 divided by 8, exactly, we have 1.5 microfarad. So you can either use 1 over C or the product over sum when the capacitors are 2 in series connection. So B, we are asked to calculate the charge on each capacitor. And we know in series the total charge is the same charge on charge 1, is the same charge on charge 2, and so on, as many as the capacitors will be given to you in series. So in this case, we can say total charge is equal to what? Charge in C1, and is the same as charge in C2. So let's find our total charge. We are not asked to find the total charge, but our total charge will be the same charge in C1 and C2. So total charge is equal to total capacitance times the supply voltage. So total charge is equal to, our total capacitance is 1.5. Our supply voltage is 240. So total charge is equal to, so let's see what we have. 1.5 times 240, we have 360. So we have 360 microcoulomb. You can also write it in this form. Total charge is equal to 360 times 10 next 6 coulomb. Is the same thing. It's the same thing. Micro is next 6, 10 next 6. All right, so let's see what we have in. So here we say B. They said the charge, B said the charge on each capacitor. So there we say, because total charge is the same as charge in C1 and is the same as charge in C2. So there we say charge in C1 is equal to 360 microcoulomb. And charge in C2 is equal to 360 microcoulomb. All right, so we are done with B. And then C, we are asked to find the PD on each capacitor. PD means the potential difference or the voltage drop in each of these capacitors. So let's derive our voltage from the voltage formula from the charge formula. So we have charge is equal to CV. So charge is equal to CV. We are looking for V. So you have to divide both sides by C. So C cancels C. So we have V is equal to charge over C. So we will use this formula to find the voltage drop in each of these capacitors in series. So we say C I. So we say voltage drop in C1 is equal to charge 1 over C1. Charge 1 is what? 360 over C1 is what? 2. So voltage drop in C1 is equal to 360 divided by 2. We have 180 volts. And then voltage drop in C2 becomes charge 2 over C2. Charge 2 is what? Charge 2 is 360. 360 over C2 is what? 6 microfarad over 6 over 6. So potential difference in C2 will give us that 360 divided by 6 will give us 60 volts. And when you add this 60 plus 180 volts, you see that you will get 240 volts. So 180 volts will dissipate in 2 microfarad and 60 volts will dissipate in what? C2. So D, we are asked to find the energy stored in each capacitor. So D, the energy, this is the formula for finding energy, half CV squared. So energy is equal to half, C is what? 1.5. Voltage is 240 squared. So let's see what we have. So half times 1.5 times 240 squared. We have 43,200 microjoules. Energy is measured in what? Joules. So microjoules. You can also write it in this form, or 43.2 times 10 raised to the power 3 microjoules is the same answer. So just follow it step by step as I show you in the video. In this video, just follow the process and you get the answer. All right, so this is the answer for this particular question. Comment below, subscribe, share my videos, subscribe my videos. As usual, sow your today and reap your tomorrow. Bye bye.